Hey guys, here's a video to help you with a couple of new, shortcuts to prove triangles congruent. If you remember, we already have side, and side angle side, but today I want to focus on angle side angle and angle side. Okay. The good news is for angle side angle, it's very much like what we did with side angle side. Where remember how in side angle side the angle had to be between? Remember we talked about the angle being between the two sides that matched up. But in this case, we actually have the side in between the two angles instead. So if you've got two angles of one triangle congruent to two angles of another, if the side between them also matches up and is congruent, well then you can use angle side angle. So again, the side in between, this is called the included side, kind of like the included angle we had before, between two angles that are, that you're focusing on. In this case, these angles are congruent, but they don't have to be congruent to each other. Okay, so just look for in between like before. Here's a better picture that has all the pieces marked for both triangles, and you can just match things up and you'll see angle B congruent to angle E, and you see segment BC congruent to segment EF, and then angle C is congruent to angle F. There's our three pieces. So again, these two angles are congruent to those two angles, and the side between them is congruent as well. That's angle, side, angle all in a row. Angle, side, angle, all in the same row. So these two triangles are congruent. So you can say triangle ABC is congruent to triangle DEF by angle, side, angle. And that's it. It's just another shortcut. So it's different pieces of the puzzle that you can use to get the triangles congruent in addition to using either side, angle, side or side, side, side. Okay? So for angle, side, it's just kind of an extension of angle, side, angle, really. The difference is you don't technically need the side in between anymore. It just has to be a corresponding side. Okay, so angle B is congruent to angle E. Oops, I should have done C first. Angle C is congruent to angle F. Doesn't really matter as long as they match up. And then the side, it's not between them this time. It's AC instead, and AC matches up with DF. But since those two sides correspond, right? If I were to have said instead of DF, if I said DE, that wouldn't be the correct side that corresponds. Remember, it has to match up. So, looking at the marks that you've already got, the only way this is going to work is if it's either AC to DF or AB to DE, if you're going to use angle, side. Obviously, if you had BC congruent to EF, you could just use angle, side, angle. All right, so this is just an extension because technically you could use the third angles theorem and get angle D congruent to A and then just do angle, side, angle. So it's just another way of shortcutting it. But you could do it whichever way you see it, as long as it matches these pieces. And of course, then triangle ABC is congruent again to triangle DEF. Oops, DEF. Okay? All right, let's see an example. And let's see. Can the triangles be proven congruent based on the information in the diagram, and then state which postulate or theorem you used? All right, so I'm looking at this picture and I see two angles congruent to two angles. And remember, these are my choices. It's either going to be side, 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 angle, side, angle, side, angle, or angle, angle, side. So I need those pieces if this is going to work. So I'm looking at this example and I see two angles. So all right, this one has two angles and that one has two angles. But do I have any sides? Is there any way I can get any pairs of sides to match up? And unfortunately, in this example, I can't. Those of you that are thinking, okay, you've got vertical angles, that's great. But you can't use angle, 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 right? That's not one of our shortcuts. In fact, that won't actually work for congruency. Okay? So unfortunately, no, because no sides congruent. Something like that. Okay? In every single one of these shortcuts, there is at least one pair of sides that are congruent. So if you can't get any sides congruent, you can't do it. All right, how about this one? This time we do have a pair of sides, awesome, and we've got a pair of angles, great. So I'm looking here and I'm looking for anything that has an angle and a side. So it's one of these three, right? I'm certainly not going to get all three sides for this one, so it's not going to be side, side, side. But what other pieces what other pieces can I get to help me figure this out? Well, again, just like before, this time we have the vertical angles that will help us. And if I look at the picture, I can see I have an angle, I have the side, and I have another angle. I have the angle, I have the side, and I have the angle. This time the side is between the two angles, so that's going to be angle, side, angle. Yes, by angle, side, angle. So again, marking your picture kind of gives this away. You have to mark it, otherwise it's going to be hard to see it. All right, how about this one? This time they've given me 3 pieces of the puzzle right off the bat. Angle with angle, side, another angle with another angle, and then this side though. This time it's a different side. It's not the side in between. But are they corresponding, right? So you have essentially nothing here and nothing here. You have a single mark and a single mark, and it's the side that connects those two. Those are corresponding sides. So this would be a yes because of angle, angle, side. Okay, some of you might say, but the angle's in the wrong spot, but that's okay. Try to imagine this if it was reflected over. Okay, literally flip this over on top, and you'll be able to see this angle matches up with that one, this one matches up with that one, and this side matches up with that side. The way this one wouldn't work is if the side was like here. Then clearly those two wouldn't match up, right? This side and that side don't match up in a corresponding way. All right, let's look at the next one. This time, again, we have vertical angles just hiding. Might as well just mark them since we see them. You know, as soon as you see them, you might as well. And then look at the picture. These 2 angles are marked as right angles, which of course are congruent because they have to be 90. We've got our vertical angles, and we've got the side in between them congruent as well. This is a perfect case of angle, side, angle. How about this one? We have a single mark, then the double mark, and then a side. We have the single mark, the double mark, and then the side. Again, this is kind of like in C, where we have 2 angles and a side not between them, but they correspond. This one you have to imagine is rotated. Okay, if you actually rotate this around, you can make this angle match up here. The blank one will match the blank one, and the double will match the double. And if you do that, then this side will fall right on top of that side. Okay, sometimes it's hard to see visually if they're corresponding or not, but you have to really look carefully. And then this last one here for this first video, we've got 2 sides and an angle. All right, let me go back to my shortcuts here. Side, 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 angle, side. So there's 2 sides and an angle here, there's 2 sides and an angle here, but the problem is you have to have the angle in between. Okay, if you remember on Tuesday or whatever day it was, I said you can't use ASS, right? We kind of joked about it, but that is not a valid way of proving triangles congruent. So if the angle is not between the 2 sides, then you can't justify it. So this would be no, SSA, and I'll write it that way on purpose instead of the other way around, is not valid. Okay, there are cases where this does end up working, but it's for different reasons. This does not justify it. Okay? All right, that kind of walks you through the basics. In the next video, I'll do the proofs, and if you have any questions, be sure and ask.